Hello and welcome. Today we'll be going through the OptiAssist for Abaqus Tutorial 8, the real-time response. This example demonstrates the function of the RTR, the real-time response option of OptiAssist for Abaqus, a separate part from the usual optimizations that have been done in previous tutorials. To begin with, I have already opened up and loaded the original tutorial 8 file, the .odb. This will be for the simple box beam, which undergoes a simple process similar to the one from tutorial 1. The real-time response enables the user to make real-time changes to the model and see how it affects the overall outcome as a prediction. To begin with, I'll open up OptiAssist and click on Real-Time Response. Clicking on Browse, I'll select the tutorial8.imp file. Click Open and then Submit, and that will begin to run automatically for you. Once the real-time response has finished running, you'll want to click on Yes to open up the PostProcessor. Under the PostProcessor UI, you will see 3 different bars representing the mass, which is the objective, the displacement of node 521, which is at the end of the box beam, and the stiffness percentage for the node. For this example, we are going to click on displacement here, and then sort through the plies by the selected response. Here you are able to make changes to any of the plies by adding or decreasing them. And the RTR will be able to change the percentage of the baseline responses according to the alterations that you make. You can then reset a single ply or reset all of them. An example of this will be to increase the ply count for the top and bottom 0 degree 2, the most sensitive from 1 to 2, which, as we can see, reduces the displacement while slightly increasing the mass and stiffness of the model. We can then see that it adds a predicted value of 25% change to the value of 18.8 millimeters. We can then click Reset. And as another example, we can then look at the least effective, the sides 45 degree 2, and add another ply to that, and then see that the change in displacement is to 23 millimeters, which is around a 7% difference. You are also able to update the model according to the changes that you make. So for this example, we'll reset the original ply before changing the most sensitive, top and bottom 0 degree 2, and then clicking Update Model. You could then run the model again through the real-time response. We'll run the updated model to create the .odb file. Once the updated model has ran through the real-time response, you can then open that up in Abaqus CAE or your PostProcessor and create a comparison between that and the original model. Here you can see the comparison between the original model and the one that has been updated through the change in the real-time response function shows a difference in the maximum displacement to about 20 millimeters. So not exactly the 18.9 as predicted, but this just goes to show that the RTR function is a prediction optimization. This concludes the tutorial.